Hey everybody, this is the 2018 FRQ number 6. So this one should actually look familiar because I'm pretty sure we gave this to you guys once upon a time when we were doing slope fields and stuff anyway. So hopefully it's not that big of a deal. Part A asks you to sketch the solution curve that passes through the point 0, 2. So let's start there. The point 0, 2. So the point 0, 2 is right here on your curve. They even drew it in there for you. Well, to follow the slope fields there, that would just be this horizontal line. Oh, that was a really bad line right there. There we go. A horizontal line going across, because if we follow the slopes, that's what's happening there. So that one's not that big of a deal. And then let's see, sketch the solution curve that passes through the point 1, 0. So that's right here. And in order to follow the slopes that's going on here, this kind of goes up and almost looks like then it's going to go towards an asymptote. This kind of goes down and maybe turns back around here and then starts to curve up that way. Oh, not quite like that, maybe. Let's make that a little bit better there. So this goes to here, then it starts to curve back up and goes like that. So it doesn't have to be exact, you guys. As long as it's following the curves there, you're good, all right? And make sure it does go to the end for both of your curves. This was worth 2 points. It's really just 1 point for each one. But like I said, make sure that it follows the curves and make sure that it does go to the ends of your graph there. All right, part B, let's see. We are asked to, we've got this initial condition and write an equation for the tangent line, use it to approximate f of 0.7. So remember, in order to write the equation of a tangent line, we need a point, which in this case we were given 1, 0, and we need a slope. All right, and so the slope of the tangent line is the derivative at that point. Well, we were given this differential function, differential equation right here. So the slope is going to be dy dx evaluated at the point 1, 0, which means just plug it in. So let's see, 1/3 times 1 times 0 minus 2 squared. And so we get 4/3. So our tangent line is y equals 4/3 and then x minus 1. So there's our tangent line, and we're going to use that to make an approximation. So I always then go ahead and change it to L of x equals 4/3 x minus 1. And I know that f of 0.7 is approximately equal to L of 0.7. So I'm going to just plug that into my tangent line. So 4/3, 0.7 minus 1. So that becomes 4/3, and this is negative 0.3. So the best way to do that without a calculator, because this would normally be a no calculator question, I understand you have one at home right now, but to do it without a calculator, the easiest thing to do is to make that negative 0.3 into negative 3/10. And so the 3's will cancel out. You can take out a 2, and we're going to end up getting negative 2/5 for our answer. So I'm going to write that just as our final answer. Then we get that f of 0.7 is approximately negative 2/5. All right. This was worth 2 points. It was 1 point for your tangent line and then 1 point for your approximation of f of 0.7. All right, and finally, we're just going to solve this differential equation with our particular solution of 1, 0. So we're going to start out by writing our differential, which is dy dx equals 1/3 x y minus 2 squared. So we need to separate the variables first. So we're going to get dy over y minus 2 squared equals 1/3 x dx. So we divided by that y minus 2 squared and we multiplied by dx. And we can put in our integral symbols now. And we're going to take the antiderivative. So if it helps, you can rewrite this as y minus 2 to the negative second dy, because that'll help us take that antiderivative. And then on the right side, let's see, we're going to add 1 to the exponent, so that's x squared. Then we need a 1/2 in front, so 1/2 times 1/3 is 1/6. And let's see here, we're going to do y minus 2. We're going to add 1 to the exponent, so we get -1. And then we need a negative in front because of the chain rule. And now we're going to plug in to solve for c. So let's see. I'm going to rewrite that as -1 over y minus 2 equals 1/6 x squared plus c. And now we can plug in that initial condition. So our y value is 0. So we'd get -1 over -2 equals 1/6. Our x value is 1 squared plus c. So we get 1/2 minus 1/6 is equal to c. If we rewrite that with a common denominator, that'd be 3/6 minus 1/6. And so we get 2/6 is our c value. And now our final step is going to be to actually solve for y. So I'm going to go back to this step up here, -1 over y minus 2 equals 1/6 x squared plus 2/6. Now you could simplify that down to 1/3. You definitely could. But when I do these problems, I always like to have a common denominator so that I can easily solve. So -1 over y minus 2 is equal to x squared plus 2 over 6. And now that I have a fraction equals a fraction, I can just cross multiply to get that y by itself. So I'm going to get -6 equals y minus 2 times x squared plus 2. So -6 over x squared plus 2. And then I would have to add 2 to get the y by itself. I know I kind of skipped that step there, but just to save us the room on it, that'll be your final answer. There are other ways that you can go about solving it, other different algebra skills you can use. You can do reciprocals and things like that. But that's the way that I've shown you guys the whole time. So there's your final answer, and this was worth 5 points. This is the typical solving for a particular solution. It's always worth 5 points. So remember to separate your variables. That's always worth a point. It's a point for each of your antiderivatives. It's a point for solving for C, and it's a point for getting to your final answer. All right, thanks for watching.